This is sample problem D.C21. The section is on finding the dimension of subspaces. So let's take a look at it. The subspace we're interested in the dimension of is this one, W. So it consists of a subset of C4, 4-element matrices, and this one uses basically 4 complex numbers, and it builds up this relationship A plus B, A plus C, A plus D, and D. Because they kind of provide us with what these coefficients are, let's just build the spanning set. So the span of W would then be equal to A times all the matrices that contain A, which is the first 3, 1, 2, 3, and the last one doesn't, plus B times all the elements that contain B, which is just the first one. So it's 1, 0, 0, 0. And then C times all the elements plus C times all of the elements that contain C, which is just the second one. So it's 0, 1, 0, 0. And finally plus D times the only ones that contain D are the bottom 2. So 0, 0, 1, 1. So this is what the span would look like of all of the elements of W. And so all we need to do then is collect these vectors into a single set. So that single set, which we can call S for the moment, is going to be 1, 1, 1, 0, and 1, 0, 0, 0, and 0, 1, 0, 0, and 0, 0, 1, 1. Now, these we know are part of this subset because all we did was expand it out. So these are the vectors that form the subset. So we know that these are representative of the subspace, this set right here. The only question we have now, we know it's a subset of W. Is it linearly independent? It certainly looks like none of these are representative of a linear combination of any others, but to check it, we can just make a matrix out of this and then do its RF. And if we do that, this is what we end up with. We end up with the identity matrix. So the RF of this guy produces the identity matrix, thus proving that it is linearly independent. So I have a linearly independent subset which spans the set. That means it's a basis and it contains 4 elements. So that means the dimension of W is equal to 4 because its basis contains 4 vectors.